All right, hello and welcome. So in this video, we're going to be starting our lessons on factoring. Um, so this is very similar to what we were doing earlier in the unit when we were talking about multiplying and dividing. So remember that factors are numbers that multiply to make another number. So, for example, if I was asking you for factors of 15, you would tell me 3 and 5 because 3 times 5 equals to 15. So, if I'm factoring a polynomial, I'm basically asking you to do the same thing, only now instead of just giving me two numbers, you're going to give me two smaller polynomials. So if I was asked to factor 16p to the power 4 plus 4p cubed, what I would want to do is look at both the numbers and the variables to see what common factors I have from both of my terms. So I'm going to go ahead and set this up using the box because it's something that we've seen before. So the first thing I'm going to do is look at my variables. So I notice both terms have a p. So if I see p in both terms, I'm going to take a p to the front. Then what I'm going to look at are the exponents. So one of my exponents is a power of 4, the other is a power of 3. So if I'm looking for my common factor, I'm always going to take the one with the lower power out to the front. So the next thing I'm going to do is look at my coefficients. So I see 16 and 4. So what I'm going to do is write down the largest common factor between these two numbers. So I know that both 16 and 4 will divide with 4 evenly. So that means my greatest common factor, or my GCF, needs a 4 as the coefficient. And then, as we said a minute ago, the p cubed is the variable. So when we say GCF, that is what we mean. And so now that I have my greatest common factor, I'll simply compare what's in the box to my common factor and figure out what goes on top that would multiply to make the inside. So if I look at my terms, I know that 16 divided by 4 would give me 4. I have p to the 4th power here and p to the 3rd power here, so I am missing 1 p. When I look at the second term, I know 4 divided by 4 gives me 1, so I need a positive 1. I have p cubed in both terms, so I'm not missing any p's. So that means I'm done with my factoring. So to get my official answer, I'm basically just going to take the two things on the outside of the box and put them as my factors in parentheses. So I'll have 4p cubed and 4p plus 1. All right, so now let's look at our second example. So once again, I'm going to make my little box. I'm going to look for the greatest common factor. So when I look at my variables, once again, I see r in both terms, so I'll bring that to the front. This one has an exponent of 5. This one has an exponent of 4, so I'm always going to write down whichever is the lowest number. When I look at the coefficients, I see -6 for both, so I'll bring that to the front. and then I'll go through and divide to figure out what goes on the top. So negative 6 divided by negative 6 is a positive 1. I see r to the 5 and r to the 4, so I'm missing a single r. I see negative 6 divided by negative 6 again, so that's a plus 1. And since my exponents match, I don't need any more r's. So my factored form is negative 6r to the 4th times r plus 1. So now let's look at what happens when we have 3 terms. So the first thing I'm going to do is check for the common factor, just like we did last time. So I see an x here and an x here, but there's not an x on the 12. So I cannot use x as a common factor. I also know that there's technically a 1 in front of this x squared. So when I look at the coefficients, 1, 7, and 12 cannot divide with the same sets of numbers, so I don't have a greatest common factor here. However, I know from when we multiplied polynomials that the 7x in the middle could actually be the combination of 2 smaller x's that we did put together. So when I set this up, this is going to turn into a division problem, but I'm kind of splitting it up into 2 rows. So I know that x squared is where I start. I know that plus 12 is where I end. And I know that that plus 7x might actually be 2 other numbers combined. So to try to figure out what numbers go in the missing spots, I know that whatever I put here and here have to multiply to make 12. So if I think of different things that can make 12, I have 1 and 12, 2 and 6, 3 and 4. If any of those can be added to make 7, then that's where I should start. So 1 and 12 doesn't help me. 2 and 6 doesn't help me. But 3 and 4 does. So what I can do is take the 7x in the middle and split it into 3x and 4x. So when I go to fill in my box, I'll put 3x here and 4x here. And if you want to switch those, it's perfectly fine because 3 and 4 add to 7, 4 and 3 also adds to 7. So once we've got our box filled in, now we just factor it like we did before. So on my top row, both terms have an x. So I'll copy that to the front. I know x times x gives me x squared, so I need an x on top. If I see 4x here and just an x by itself here, then I know I need a plus 4 on the top that's missing. If I see a 3x here and just an x by itself here, then I'm missing the 3, so I need that in the front. And so if I did this correctly, then the 3 and the 4 that I placed on the outside should multiply to 12, and they do. So to write down my factors, I'm just going to take, once again, the things on the outside of the box and group them in parentheses. So on the side, I see x plus 3. And on the top, I see x plus 4. So in this example, we'll notice it's once again 3 terms. Once again, we don't have a common factor, so we're going to do the trinomial factoring once again. So just like last time, I know the 2x squared is where I start. I know the minus 10 is where I end. And I know the 1x in the middle could be the combination of 2 other x's. So the only difference between this one and the one we just did is that I've got this extra 2 in front of my x squared. So when I'm trying to figure out what goes in the middle, I need to combine the numbers on the outside by multiplying them, and then look at the factors of that number. So 2 times negative 10 is negative 20. So to figure out what goes in the middle, I'm looking for factors of negative 20 that can subtract to 1. So I know I can do 1 and 20. I know I can do 2 and 10. I know I can do 4 and 5. So just like last time, since I see a negative, right, I'm going to need to subtract because one of my numbers has to be positive and one has to be negative. So if I subtract 1 and 20, I get 19. That's not helping me. If I subtract 2 and 10, that gives me 20. That's not helping me. Or sorry, I should say 8. But if I subtract 4 and 5, it gives me 1. So I'm going to take the 1x and split it up into negative 4 and positive 5x. So notice that if I flipped that the other way, 4 minus 5 would give me a negative number. So that's how I can tell which sign is supposed to be positive and which number is supposed to be negative. And again, I'm just going to take those two and fill in the missing spots. So I need minus 4x and plus 5x. So double checking, 5 minus 4 gives me 1, so everything looks good. And so from here, we're just going to factor like we did last time. So on my top row, I see an x in both terms. If I have an x on the side, I need a 2x on top to make 2x squared. If I have an x on the outside and a 5x on the inside, I'm just missing the 5. And then on my bottom row, if I see a 2x on top and a negative 4x on the inside, then I need to multiply by negative 2 to turn the 2 into a negative 4. And once again, if I did this correctly, negative 2 times positive 5 should match with my negative 10, and it does. So just like last time, we're going to take the numbers on the outside and group them into factors. So the order that you write them technically doesn't matter, so you can do the side first or the top. And since I like to see the coefficients in front of x first, I'll do the 2x plus 5. Either way, the answer is correct. So my final answer for that would be 2x plus 5 and x minus 2. That's all I have for this one. I will see you guys next time.